video, we shall discuss all the characteristics function of a random variable. We are also to derive some of the standard distribution. In this case, the standard gamma distribution. The first thing to write is to write the distribution for the standard gamma distribution. For more on this topic, you need to subscribe to this channel. So the standard gamma distribution can be written as x into alpha minus 1 exponential negative x all over the gamma function. Now, we also know that our characteristics function is equal to the expectation of exponential itx, which is also equal to the integral from 0 to infinity. Then we have exponential itx multiplied by f of x, then dx. The I is our characteristics function, and this is the distribution. So all we need to do is to impute the distribution for the standard gamma distribution into our characteristics function to get its derivation. It then means that our characteristics function will be equal to the integral from 0 to infinity exponential itx multiplied by, now we have to write the standard gamma distribution, which is x raised to the power of alpha minus 1 multiplied by exponential negative x all over the gamma function, then dx. As we know, this is not a constant, so we'll bring it out. We move over to this other side. It then means that our characteristics function will be equal to, we are bringing the gamma function out. We now have 1 all over the gamma function into from 0 to infinity. Now we bring this out, x raised to the power of alpha minus 1. If you find this video helpful, you need to subscribe to this channel. Multiplied by exponential, we have negative x multiplied by, we have exponential I tx, then dx. So we have our characteristics function to be equal to, now all we need to do is to rewrite this out properly. So we can write it as our gamma function into, we have our x alpha minus 1 exponential negative, say 1 minus, this is 1 minus it, then x dx. So we have this here. So we have succeeded in writing this out properly. Of course, we know that from our gamma function that this thing we have written means our gamma function all over 1 minus it, then alpha. So the whole of this implies this. The next thing to do is to now rewrite our characteristics function. So our characteristics function of x will be equal to 1 all over our gamma function multiplied by the whole of this, which is this. So we'll have our gamma function all over 1 minus it alpha. Of course, this will cancel this. For more on this topic, you need to subscribe to this channel. If we cancel it, it then means that our characteristics function for the standard gamma distribution will give us 1 all over 1 minus it alpha. So this is what we get as the derivation for the standard gamma distribution. For more on this topic, you need to subscribe to this channel.